Okay, we're going to talk about alkenes. Alkenes are a family of hydrocarbons, so that means they contain only carbon and hydrogen, like the alkanes, but they also must contain a carbon-carbon double bond. Sometimes when molecules contain a carbon-carbon double bond, we say they are unsaturated. That refers really to the amount of hydrogen, they're not saturated with hydrogen. If you look at the formula of ethane, it's C2H4, C2H6, ethane, whereas ethene is C2H4. It hasn't got as much hydrogen in it as ethane because of the double bond. That's where that word unsaturated comes from, anyway. Right, so here we have got ethene. The formula that would be C2H4. Here we've got 3 carbons long, so we call that propene. C3H6. So we can see the general formula of the alkenes is CnH2n. Unlike the alkanes, of course, which the alkanes are, they've got 2 extra hydrogens. CnH2n plus 2. Right. Ethene and propene are both gases at room temperature. So if you do experiments with them in class, you usually don't use either of those two. You would use something like hexene here. Hexene, 6 carbons long, so that's going to be C6H12, double the number of hydrogens as for carbons, and hexane, of course, would be C6H14. Now, I've drawn them burning there on watch glasses. If you burn alkenes, you notice that they burn with quite smoky flames. Okay, and that's because they've got they've got more carbon in them compared to hydrogen. So that means they're not that good as fuels, but alkenes in a way it's all pretty to waste them as fuels, just burning them, because they're a lot more reactive than alkanes and they can be used to make other more useful things. Right, so if we just look at the combustion reaction for, let's do it for hexane, that would be C6H14 plus oxygen. We get CO2 and water. This is for the alkane. Well, you're going to form 6 carbon dioxides. You're going to form 7 waters. So how many oxygens do we need? Well, we have on this side of the equation, we've got 6 times 2 in the carbon dioxide, that's 12, plus 7 makes 19. So that we're going to, so that is actually 8.5 O2, sorry, 9.5 O2 molecules. If you don't like it halves and you're balancing, we have to double everything. So let's double that. So we're going to have 19 oxygens. We're going to need 2 of those. That means we're going to form 12 carbon dioxides. And we have got 28 hydrogens. That means we're going to form 14 waters. And if we do the same for the hexene burning, well, we've got C6H12 there, plus oxygen. They give us CO2 and water again. Well, we're going to have 6 carbon dioxides. We're going to have 6 waters. So that gives us number of oxygens on the right hand side. We've got 12 in the carbon dioxide, 6 times 2, and plus 6 there, that's equal to 18. So that's just 9 O2 molecules. It's a bit easier to balance than the last one. Okay, but it's the same products, carbon dioxide and water. Now, when alkenes react, and they are, as I say, they are more reactive than alkanes, they can do other things than just burn. What happens is the double bond breaks, and this is this reaction forms the basis of the test for an alkene, or test for a double bond, carbon-carbon double bond. So what you do is you add a few drops of bromine water there. So bromine water is a reddy brown color, an aqueous solution. So you add bromine water. If a double bond is present, the bromine water is decolorized. So it goes colorless. Doesn't go clear, it's already clear, it gets decolorized. So it's quite important to say that. I always ask that question in exams. Okay, so let's add some bromine water to hexane first of all. Now, what happens is, when you shake it up, and you see that the red color stays. Why have you got two layers there? Well, that's because hexane and water don't mix. Okay, so this is the water at the bottom that you've added with the bromine water, and this is the hexane. Now you can see there, don't worry why, but the bromine much prefers dissolving in the hexane rather than the water, so the water goes almost colorless. The red color goes all into the hexane layer. But the important thing is no decolorization takes place, so no double bond. You do the same with hexene, and you will see that the bromine water decolorizes, showing you have got a double bond. There will be the aqueous layer then, and this will be the hexane plus the product, the hexene, sorry, hexene plus the product that it's formed, which we'll talk about in a minute. And again, those two don't mix with each other. But the important thing is no red color left. The bromine has been decolorized. Now we need to look at this reaction in more detail. This is actually called an addition reaction. Now, all alkenes undergo addition reactions, and what happens is the double bond breaks, and two different things add on to the other atoms add on to the carbon. Right, I'll illustrate what I mean by that here. Right, so here we've got ethene, and you shake that up with a bit of bromine water. What happens is, now there's two bonds are going to break. The double bond, the single bond remains intact, and the bond between the two bromines. Now we know carbon likes to form 4 bonds, so if we break that bond, it means the carbon's only forming 3 bonds. You can see from this diagram here that bromine likes to form 1 bond, and what happens is that bond breaks, and the bromines, one sticks on there, one sticks on there. So the carbon's got 4 bonds, okay, and you will form that product, and that's why it decolorizes bromine water. This product is also colorless. The bromine, of course, this bromine here is reddy brown. Now all the halogens will all react with alkenes in that way. So again, if we've got chlorine, and iodine here, chlorine and hydrogen. We've got here. Just got chlorine first of all. You're going to break the double bond, and you're going to break the bond between the 2 chlorines. That's going to form this molecule where you've got 1 chlorine stuck onto each carbon atom. Again, if you just get chlorine water and shake that up with an alkene, that will work. Now, this hydrogen will also do the same thing, but in this case, you do need to heat it, and you need the catalyst, and the catalyst is actually made out of nickel. And this is actually quite important industrial way of getting rid of double bonds. It's carried out a lot of the time. Okay, so here we're going to, what will happen there is you'll just turn the ethene, break the double bond, break the bond between the 2 hydrogens, and you form new bonds. So you get 1 hydrogen stuck there and 1 hydrogen stuck there. So you formed ethane from that. Iodine will act in exactly the same way as chlorine, so I won't bother. I2 does exactly the same thing, so we won't bother showing that. But what we'll show here is water. Now this is quite important. This is very important. Okay, right, water. Well, we're going to break one of the bonds between the hydrogen and the oxygen, and we're going to break the double bond again. And what happens is you form, right, now the hydrogen sticks onto one of the carbons, and the OH here, from the rest of the water, sticks onto the other carbon. And you probably know that when you have an OH on that molecule there, it's now called an alcohol. And this alcohol is actually called ethanol. Ethanol is used as a solvent in lots of things in the chemical industry, and this is a major way of making ethanol. So you get ethene, and it's reacted with steam, and you end up with ethanol. That's industrially a very important process. Okay, but again, it's an addition reaction. Right, let's just look at some other alkenes. Let's see what happens if there's propene. Let's see what happens when we react with that with bromine. Well, it's exactly the same as ethene. You're going to break the double bond there. You're going to break that, and you will form. The carbon's got hydrogens on it. It's got one, and you will form. So you stick in on a bromine onto that carbon, and a bromine onto that carbon. Let's see how propene, this is propene, let's see how that would react with water. Now we need to be a little bit more careful there. Something else could happen, as we'll see. Okay, now we're going to split up propene, right? And so we're going to break the double bond. Now you can see that that carbon there is not the same as that carbon there. Whereas in ethene, both of those carbons are exactly the same. But here it's different. So let's see what could happen. There's two things that could happen. We could, first of all, we're going to break the double bond, so that goes. Now it could happen that we stick the hydrogen onto here, and the OH bit from the water, because we're going to break the bond there, onto the N carbon. That's one possibility, but of course the other possibility is that they could go the other way around. So you could end up with, we've got 3 hydrogens here. You could stick on the hydrogen on the N carbon and have the OH going on the middle carbon. So you end up with 2 slightly different versions of propanol. These are both propanol, but they're slightly different. In actual fact, one's called propan-1-ol, which you don't need to know, and one is called propan-2-ol. And they're very similar molecules, but they're not exactly the same as each other, and they are a little bit different. And that is caused by the fact that, as I say, that these 2 carbon atoms in propene, that one and that one, are not exactly the same as each other. The molecule is asymmetric. Okay, so that's all we need to know about alkenes. They burn with smoky flames, and they undergo these addition reactions where you end up breaking the double bond. Remember how to test for an alkene, decolorizes bromine water, and also remember that ethene reacting with steam is a very important way of making ethanol.